वेलकम बैक माय डियर स्टूडेंट्स, वेलकम बैक। स्वागत है बेटा आप सभी का। यूर ऑल वेलकम। वेट बेटा। Okay beta, now please confirm me everyone, audio video crystal clear to all of you? Are you all able to hear me, see me beta? Confirm me. Please confirm me everyone beta, audio video crystal clear to all of you? Can we proceed? Can we proceed? Tell me beta everyone, just write CC in comment section if you are all able to hear me, see me. अगर आप सभी देख सकते हो, सुन सकते हो, then please write crystal clear in comment section so that we can start today's lecture. Okay, so my dear student, now we are in lecture number 3. That will be final part of main core syllabus of diffusion, and this is part 3, not part 2. Mass transfer operation part 3, and diffusion continued. Today we will finish its core part of diffusion. Once again, you're all welcome. As you all know, this side Gaurav Srivastav Sir from IITBHU, from GATE Chemic Learning App, with 14 plus years of teaching experience as GATE Chemical Engineering author, educator, multiple GATE top rank. I have GATE 2025 AIR-43. Okay, so now without any delay, I'm going to start today's lecture, and few important things again I want to share with you guys. As you all know, this is crash come full course beta, crash come full course. So I'm not going to leave a single topic here beta. Okay, just we will skip unimportant derivations. Okay, unimportant derivations, and numericals I will give you, and now you have to practice because I will provide you numericals along with solution, and few also important few numericals I will discuss in this live lecture. Okay, if you don't know Hindi, you are totally purely English learner, and I am using any Hindi line or Hindi word, no need to worry, but that means just I am translating my last line, because the main language of this lecture is English. Okay, so I hope no need to worry for anyone. जस्ट आई विल यूज हिंदी सो दैट हिंदी लर्नर्स कैन ऑल्सो फील। ओके, हिंदी लर्नर्स को भी जो हिंदी फील हो थोड़ा, ठीक है, इसके लिए थोड़ा हिंदी हम बीच में यूज करते हैं। सो नाउ आई एम गोइंग टू स्टार्ट टुडेज लेक्चर बेटा। एवरीवन जस्ट वन मोर टाइम बेटा, प्लीज राइट क्रिस्टल क्लियर इन कमेंट सेक्शन सो दैट वी कैन मूव फॉरवर्ड बेटा। सभी लोग फटाफट बता दे बेटा, ऑडियो वीडियो क्रिस्टल क्लियर। क्या हम स्टार्ट कर सकते हैं आज की क्लास को? एवरीवन प्लीज कंफर्म मी बेटा। Okay, fantastic. So, wait. Today we are not going to start second chapter. We will finish chapter number 1. Okay, then in next lecture we will start second chapter, that is mass transfer coefficient. So today first topic is diffusion in solids. Diffusion in solids. Now, when you are going to see this topic, that is diffusion in solids, definitely you think about Knudsen law. So my dear student, this is the topic that is relating Knudsen law, but as well as with Fick's law. You can also use Fick's law. But when to use Knudsen law, when to use Fick's law, don't worry. Just focus here. Any doubt, then ask me. So diffusion in solid. Which type of solid? These solids are porous in nature. These solids are porous in nature. And a little bit you can tell that it is analogous to CRE, that is chemical reaction engineering chapter, intraparticle diffusion. Intraparticle diffusion. Like this is particle and these are respective pores. These are pores. These are pores. Okay, some fluid, you can tell here reactant is going to enter here, and then they are going to adsorb with surface reaction happens there, then product formed. So these things definitely you had seen in CRE. ये आप लोगों ने CRE में देखा होगा. You had seen these things in CRE. Okay, wait. Okay, now it is visible to all of you. So here similar thing we are going to see, but this time diffusion in solid. So as I told you earlier that you can classify one case, that is diffusion in solid followed Fick's law, and the second case, that is diffusion in solids followed Knudsen law. Fick's law, Knudsen law. Now, how to differentiate when to use Fick's law or when to use Knudsen law? Two terms will be there. One is pore diameter. One is pore diameter, and the second thing is one is pore dia, and the second thing is mean free path. Mean free path. Okay. So two cases you can see. In one case, when the pore diameter is more than mean free path, this is what? This is mean free path. This is mean free path. Okay. Sorry, this is mean free path. This is mean free path. So one thing you have to see here, when the pore diameter is more than mean free path, in that case, you are going to use Fick's law. These type of diffusion in solids are going to follow Fick's law that already you had seen. And in these type of cases, structure of solids are not important. Why it is not important? Because diameter itself is higher in comparison to mean free path. But if the mean free path is more in comparison to diameter of pore, then they are going to follow Knudsen law. And just you can feel like this this is suppose pore. So in this manner, internally reflected, total internal reflection, I think you had seen in physics, optical fiber chapter. So similar type of diagram here you can also see. So two cases are there. How you are going to differentiate them? Based on this. Okay, so if pore dia is more, then follows Fick's law. If pore dia is less, then follows Knudsen law. Here structure is not important. Here structure of solid are important. Now see one by one. What is mean free path? I already told you. Total path traveled upon number of collision, that is known as mean free path. Mean free path. Now two cases, just as I discussed with you. In one case in which mean free path is more. If mean free path is more, that means diffusion follows Knudsen law. That means this is the case of Knudsen. This is the case of Knudsen law. Okay. And when the diameter is more beta, then this is the case of Fick's law. This is the case of Fick's law. ये आपका Knudsen law है, ये आपका Fick's law है. Because here diameter is less, mean free path is more. So before colliding with any other particle, suppose this is one particle, this is second particle. So before colliding with each other, they are now going to collide with, strike this wall. They are going to strike the wall. So again after striking, their direction changes, and in this manner your particle is now moving from one point to another point. This is the basic of Knudsen law. And if their mean free path is less, that means they are moving like this. बिकॉज यहाँ पे आपका पोर का डाया कम है, मीन फ्री पाथ ज्यादा है, तो ये अपने पाथ को चलेंगे. सपोज जितने देर बाद टकराते हैं, तो अभी कहाँ टकरा पाए, उसके पहले ये वॉल से ही टकरा जाएंगे ना. जबकि यहाँ पे मीन फ्री पाथ कम है, तो यहाँ चला, यानी कि इतने पे ही टकरा जा रहा है पोर तक, ये वॉल तक नहीं पहुंच पा रहा है. ओके, सो दिस इज द बेसिक अबाउट Knudsen law. These are the basics about Knudsen law. and fixed law. And these both cases relating diffusion in solid. Okay. Now one by one again see diffusion in solids followed fixed law. Here you can see similar type of formula you are going to use that you had seen in our lecture number 1. Fixed law of diffusion. That is Na by A equals to minus DAB dCA by dZ. So nothing to worry. Nothing to worry. Okay. You can see two more terms are here. One is epsilon and one is tau. What is epsilon and what is tau? Actually, this epsilon is related with this area, and this tau is related with this dz. In a previous case, dz was the actual distance that was traveled by your particle for diffusion. by dz actual distance था जिससे आपका पार्टिकल चल के जा रहा था डिफ्यूज होने के लिए, और एरिया आपका वह एरिया था जिस एरिया से डिफ्यूजन हो रहा है. Suppose this is the solid, and here diffusion is going to occur, and as you had seen, these are going to occur by pores. So the actual area that is available for diffusion is this area, not complete. Complete area is not available. Only area available, that is you can see here of pores. ये जो pores का area है यही आपका यहाँ पे available है. ये जो pores का area है यही यहाँ पे available है. ठीक है. So what you are going to do, suppose this pores having area of fractional 0.4. So if you are going to multiply with total area, pores area fractional, how much fraction of this pores multiplied with total area, it is going to give you actual area beta. It is going to give you actual area. ये आपको क्या दे रहा है, ये आपको दे रहा है actual area. It is going to give you actual area. So that's why this epsilon is present along with this. Now A epsilon, this is epsilon. So A epsilon is going to give you effective area of diffusion, and clearly you can see effective area of diffusion is not equal to cross sectional area. Okay, here I will see comment only if required beta, because this is crash come full course, so I can't read too much comments. So just ask me problem whenever you feel. Okay, and just try to concentrate. Speed will be little bit high. If you are also feeling, then you can ask me to slow down, but I don't think so, because this is crash come full course. Okay, so Na by A equals to epsilon dAB by tau dCA by dZ. Now how this tau is going to use here? यहाँ tau क्यों use कर रहे हैं? Because suppose this is the case, this is the solid, and diffusion is occurring in this manner. Suppose some particle A is going to come from this side and going to diffuse to this side, and now this particle have to pass this solid. इस particle इस solid को pass करना है. Now how they are going to pass? ये कैसे pass करेगा? ये कैसे pass करेगा? अगर ये ऐसे आ रहा है, जा रहा है, तो सीधे सीधे pass कर जाए. So this is the distance z ना, or in differential form this is dz ना. But here you are clearly seeing that the things are happening along with by pores. The things are going along with pores. They are not going to adsorb by solid. They are passing through solid. So maybe pores are available like this. Instead of straight pore, maybe pore is like this. So actual distance that is going to travel is like this now. Not. This is not. No, this is the actual case now. So how you can use this z or dz? You have to write actual distance now, or actual distance traveled by that particle in order to transfer from this point to this point. So that's why this tau is coming here beta. इसलिए tau यहाँ पे आपका आ रहा है, and this tau is known as torcicity. Torcicity, that is actual distance upon minimum distance. And in these all cases, what is minimum distance? If this is the solid, then this is the minimum distance. This is the minimum distance. This is the minimum distance. And suppose, just I am taking one example. Suppose a typical example I am taking. Some particle is available at this point A, and actually they are moving towards this point B by this path that you are seeing, but I don't know how to write it. How to write it हमें नहीं पता भाई, ये actually ऐसे गया A से B. So now I am going to write, this is my Z actually, ये हमारा minimum distance है जो A से B तक पहुंचने के लिए आप ले सकते हो. This is minimum distance. So this is your actual Z. This is your actual Z. But how you are going to use this Z? You need this actual distance, na? You need this actual distance. This is a actual distance, na yaar. So if I am going to write tau and that tau is actual upon minimum, then actual can be written as tau into minimum na. See, same thing here beta. So tau and epsilon, two terms, extra term will be there. So I don't think that it is difficult for you beta. Okay. Is it clear to all of you beta? Don't worry beta, torque HP. Don't worry, torque HP. Okay. Now, see, if they are going to follow Fick's law, then in these type of cases, this diffusivity DAB are now going to follow Arrhenius type equation. Now I hope in chemical reaction engineering in CRE you had seen this equation, K equals to K naught e raised to power minus EA by RT. K equals to K naught e raised to power minus EA by RT. This EA is what? This EA is activation energy in that case. K naught pre-exponential factor. R universal gas constant, T absolute temperature, and this K was reaction rate constant. Now, just see analogous nature. Similar type of equation here also you can see. When diffusion is occurring in solids follows Fick's law. Then in that case you can write C DAB as D naught e raised to power minus HD by RD, where this EA was activation energy. This EA was activation energy, whereas this HD is diffusional activation energy. In previous case you had seen activation energy normally is not a function of temperature. Same to same here also, this diffusional activation energy is also not a function of temperature. This K naught was pre-exponential factor. Similarly, my dear student, here this is also pre-exponential factor, that is a constant. Now from this typical gate problems can be asked just like this Arrhenius equation. So by taking logarithmic, just you can see you can convert this equation to this form. Very easy. Okay. And they can ask you if at this temperature the value of, they will tell you if the diffusivity is following Arrhenius type of equation, then if the value of diffusivity at temperature T1 is DAB1, and if this is the diffusional activation energy, then what will be the value of diffusivity at temperature T2? One equation, one unknown. Very easy. Totally you can see similar nature just as you had seen in case of reaction rate constant in CRE, chemical reaction engineering. Okay beta, is it clear to all of you? Is it crystal clear to all of you beta? For any other type of question beta, just call me 9451707049. Just here talk about this lecture, no other comments. Okay, just talk about this lecture, no future, no past, what to do in future and how sir we are going to do things. Just see this lecture. For any other thing, just directly call me after lecture. Okay, so I hope beta everyone crystal clear. Just tell me, is it clear to all of you beta? Is it crystal clear, my dear students? Crystal clear beta Pranjal? Very good, fantastic, mind blowing, super. Now, so I hope till now the things that you had seen very easy. Just these things you have to remember, and very easy to remember. Why? Because Knudsen total internal reflection is there. So automatically you will get it. If something is like this type of mean free path, then they can hit wall. But if mean free path is less, then they are not going to hit wall immediately. They are going to collide with some other particle before hitting the wall. So if this is the case, this is the Knudsen law. If this is the case, this is the Fick's law. So very easy. Very easy. Okay. So these things also crystal clear. You are not going to do mistake like you are not going to write tau by epsilon. Automatically you will get tau. You are not going to multiply with this a, because this tau is going to convert this distance to actual distance. This distance to actual distance. Okay. क्लियर बेटा? चलो बहुत अच्छे. Now see same type of graph here also you can write. This was the equation by taking logarithmic ln of DAB versus 1 by T. This is the graph. And slope is minus SD by R. Minus ESD by R. This is the slope. Negative sign, that means slope is coming like this. If positive, then it will come like this. But here slope is clearly negative. Slope कैसा आ रहा है बेटा? Negative आ रहा है. Now clearly you can see बेटा, R is a constant value. But if you are going to change component, अगर आप component को बदलोगे, then what is going to happen here? If you are going to change component, then clearly my dear students, HD is going to change. HD is not going to change with temperature, but it is going to change with component ना यार. अलग अलग component का activation energy अलग अलग आएगा ना यार, diffusion activation energy. So maybe some have high, some less. So if you are going to increase it, what will happen? The graph will look like this. Slope will increases. If the magnitude of slope will be increases. If it is going to decrease, then it is going to like this. So दो अलग अलग तरह के आएंगे. And again my dear students, if you had already completed Arrhenius equation and their respective significance, then this topic is very very easy for you. बहुत ही ज़्यादा आसान है. ठीक है? Now see the same thing here. High DAB, high HDA, that means high slope. Low means low slope. Low means low slope. And in this graph, this is the high temperature region, this is the less temperature region. And the similar here also, I want to give you one conclusion here. First is diffusion is more sensitive to temperature for higher value of diffusional activation energy. See, if this is the case, just by changing this amount of temperature, this is the change. This is the change. But if this is the case, you can see the change is very very low. So low DAB less sensitive, high DAB more sensitive. तो सेम यहाँ पे आपको वही हमने कंक्लूजन दिया है. Diffusivity is more sensitive to temperature for higher value of diffusional activation energy in comparison to lower value of diffusional activation energy. Okay, R is gas constant. Why we are using in solid? Beta Rakesh, here few things I can't explain due to less time. बेटा यहाँ पे थोड़ा कम समय है, इसलिए हम लोग इस बता नहीं सकते ज़्यादा कुछ यहाँ पे हैंडल आपको चीज़ें. और बस ये जान लो कि आर गैस कांस्टेंट है, बट ऐसा नहीं है कि गैस कांस्टेंट केवल गैस के केस में ही आप पाओगे. बहुत सारे एनालॉगस नेचर में आप पाओगे कि उसका इस्तेमाल किया जाता है. और यहाँ पे डिफ्यूजन जो सॉलिड में हो रहा है वो आपका गैस भी तो हो सकता है. अगर आप कंफ्यूज हो तो ऐसे भी देख सकते हो. ओके, नाउ आई होप क्रिस्टल क्लियर टू ऑल ऑफ यू. आई होप क्रिस्टल क्लियर टू ऑल ऑफ यू बेटा. Crystal clear? Because beta see, Arrhenius equation that you are going to use in a chemical reaction engineering, even if the liquid reactant is there, you are going to use the same equation many times. due to analogous nature, बहुत जगह analogous nature पाया जाता है और उसे ही इस्तेमाल हम लोग करते हैं. So Arrhenius equation is it what is Arrhenius equation? It is just inspire and ignite type equation. First Clapeyron, then inspired want Hoff equation. Want Hoff and gives want Hoff equation. And Arrhenius inspired with want Hoff equation and gives Arrhenius equation. तो ये दूसरे के इक्वेशन को देख के इंस्पायर होके जब अप्लाई कर रहे हैं तो पा रहे हैं कि ये इस केस में भी ट्रू है. इस तरीके से ये इक्वेशंस आई है बेटा. आर यू गेटिंग माय वर्ड्स राकेश? Is it crystal clear beta how these equations come? Because no direct derivation here, no direct derivation here. These are inspired. अरे उन्होंने किया था तो के ई लिया था, equilibrium reaction rate constant. Now if we are going to use just any forward or backward reaction rate constant, is it still correct? Yeah, it is correct. But they used heat of reaction. We have to use a different type of term instead of heat of reaction, that was activation energy. तो इस तरह से इंस्पायर्ड हुए और वो उन्होंने नया इक्वेशन दिया. ओके, सो क्लासियस एंड क्लैपेरॉन वाला जो इक्वेशन था, क्लासियस क्लैपेरॉन फॉलोड बाय वांट ऑफ, देन फॉलोड बाय आर्हेनियस. एंड हियर आल्सो एप्लीकेबल. चलो बहुत अच्छी बात है. फैंटास्टिक, माइंड ब्लोइंग, सुपर. सो this is the conclusion number 1. And see here one more conclusion. Diffusion is more sensitive at lower temperature. Actually this graph is semi log graph. You can see semi log graph. This side logarithmic, this side 1 by t. So if you are going to take one side log, one side just temperature 1 by t. So this is their respective high temperature region, this is their respective low temperature region. And you can see by calculation, because this is 1 by t, I can't prove here in this crash course. In detailed course I proved everything, but here just listen and immediately just learn it. Okay, so diffusivity is more sensitive where? At lower temperature. This is low temperature region, because this is 1 by t. If only t, then this is low, this is high, 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 high. But 1 by t, so low, high, 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 in this manner. So low temperature region, high temperature region. After studying one more conclusion is that diffusivity is more sensitive at lower temperature. मतलब लोअर टेम्परेचर पे अगर 10 केल्विन से डिफ्यूजिविटी डबल हो जाती है, तो हायर टेम्परेचर पे यही आपको 120 केल्विन करोगे तब जाके डबल होगी. तो यहाँ सेंसिटिविटी इसकी ज्यादा हो गई ना यार. डबल कब हो रही है? यहाँ केवल 10 केल्विन, यहाँ 120 केल्विन चाहिए. सो डिफ्यूजिविटी इज मोर sensitive at lower temperature. So these two conclusions, I hope everyone crystal clear. Now second is diffusion in solids follows Knudsen law. अब ये क्या है यार? Knudsen law को इस्तेमाल करते हैं तो क्या होता है? So for this case बेटा, you have to learn one equation, how to calculate Knudsen diffusivity. In GATE examination they can ask you 1 mark or 2 mark question directly based upon this formula, and already asked in PYQs, you can see it. So Knudsen diffusivity, that is dk equals to 2 by 3 rpv average. दिस इक्वेशन इमीडिएटली प्लीज लर्न इट बेटा, इसको तुरंत याद कर लो. व्हाट इज आरपी? पी फॉर पोर, दिस इज रेडियस ऑफ पोर. व्हाट इज आरपी? रेडियस ऑफ पोर. व्हाट इज वी एवरेज? दिस इज एवरेज वेलोसिटी. You can write average velocity value with the help of kinetic theory of gases. It is 8 RT by pi m square root, that is power 1 by 2. R again universal gas constant, T again absolute temperature, and m is molecular weight of that fluid. M is molecular weight of that fluid. Now, this is the very, very important formula. If they are going to ask in examination, 98% chances are there that they are going to ask this, or 2% chances are there that they are going to ask complete flux in this Knudsen case. So overall, most important thing is Knudsen diffusivity. So please remember it. And now you can see formula still remains same. Just instead of diffusivity, you are going to use Knudsen diffusivity. And same formula fixed law. Same formula fixed law. And CA can be written as PA by RT with the help of ideal gas equation. You can see. You can see P equals to nRT, P equals to n by VRT, n by V, mole point volume, that is concentration. So if you are going to write for any particular component, then PA equals to CART. And CA will be PA by RT. Okay. So here nothing is special. It's a very, very easy. Only one formula that you need to remember. Please remember it. Please beta remember it. Very important. Okay. Based upon that formula, see beautiful problem. Just clearly based upon formula. Here I am going to explain, but beta all numericals that I am going to explain here or not explain here, just given as homework. All you have to practice just one more time, beta. Just one more time. Okay, so what is the value of Knudsen diffusivity of ethylene in a 100 angstrom diameter pore catalyst at 600 Kelvin in centimeter square per second? Right answer into 10 raised to power minus 2 up to 2 decimal places. Angstrom means 10 raised to power minus 10. So dp will be in meter, 100 into 10 raised to power minus 10. Rp, that is radius, so half of diameter. So I am going to write it's 50. Temperature given. Because ethylene is given, the formula of ethylene is C2H4. 12 to the 24 and 4, 28. R, this is universal gas constant. I want in my unit, so in place of kilopascal, I am writing pascal. So K is prefix whose value is 1000. So 8 point is now converted to 8314. Now just I am going to put here all things. After calculation, this is in meter per second. This is in meter, sorry, not meter. Yeah, it is velocity, meter per second. Now after putting here, it is coming in meter square per second. So don't forget to convert in meter centimeter square per second. So just done conversion here, and now final answer 2.25 into 10 raised to power minus 2. So because 10 raised to power minus 2 already given here, so we have to fill here 2.25. And please again do it, because maybe you are not able to calculate it in your calci में भी आपका आंसर आना चाहिए. तो क्वेश्चन सीधे फॉर्मूला बेस्ड है, इसका ये मतलब नहीं कि आप लगा ही लोगे. आपको घर पे री प्रैक्टिस करनी ही करनी है, जितने भी प्रॉब्लम्स हम आपको यहाँ पर देते हैं. ओके, इज इट क्रिस्टल क्लियर टू ऑल ऑफ यू? बिकॉज इन डिटेल्ड कोर्स टाइम भी देते हैं कि लाइव क्लास में आप प्रैक्टिस करो, बट यहाँ लाइव क्लास में प्रैक्टिस का टाइम आपको नहीं दिया सकता है, बट यू हैव टू प्रैक्टिस इट अगेन. अगर आप कराते भी हैं लाइव क्लास में तब भी आप एक बार प्रैक्टिस करते हो, तो यहाँ पे फास्ट टेक्निक्स को हमने बता दिया कैसे सॉल्यूशन होगा, सब दिखा दिया। अभी आपको वापस से करना है, अगर फंसोगे तभी इसका सॉल्यूशन वापस से आप देखोगे, ठीक है। सो आई होप एवरीवन क्रिस्टल क्लियर दैट यू हैव टू प्रैक्टिस ऑल न्यूमेरिकल्स गिवन बाय मी इन दिस क्रैश कोर्स, okay, one more time. Now see, this is just I had shown how this its unit is meter per second, okay. Now these are extra practice questions from previous topic that we had already completed in lecture number 1 and 2, and as written extra practice. So if you don't have enough time, then you can leave extra practice questions, just पे extra practice लिखा है, because this time just less than 3 months, approximately 2 months left. So you have to leave extra practice question if you feel that still other subjects left for you, okay. So this is extra practice question, and solution also given by me here, okay. Now next topic is liquid diffusion, surface diffusion and self diffusion. So ये वाला आपका क्लियर है टॉपिक, फटाफट बता दो सभी लोग, इज इट क्रिस्टल क्लियर? कैन वी प्रोसीड बेटा? कैन वी प्रोसीड? इज इट क्रिस्टल क्लियर बेटा? Is it crystal clear, my dear students? Chalo, very good. So now these three topics are very, very easy: liquid diffusion, surface diffusion, self diffusion. Okay. What is the meaning of liquid diffusion? You had already seen previous beautiful equation that you developed, and told that equation as mother equation of diffusion. Na by A equals to Nxa by A minus Dab Dca by Dz. But when you're going to apply to a liquid system, then you can't apply that equation there directly. Why? In case of gas, total pressure will remain constant. Total pressure as well as absolute temperature of both sides will remain constant. But if some liquid is here, liquid A, liquid B, liquid component A, component B in liquid form, then clearly here density and here density, it is not same. And because A and B are present in different proportions, so their respective average molecular weight in this chamber number 1 and in this chamber number 2, this is also not same. So if you are going to write total concentration here and here, then in gas case it is same, because C is nothing but P by RT. P same, T same, are already universal gas constant. So C is not going to change. But in this case, beta, total concentration of both chambers are not same. So that's why we need some special attention for this liquid diffusion case. And very, very easy. Very, very easy. Here I'm not going to derive it, as I already told you in crash course. We have to skip derivations. Okay, only we will discuss most important derivations. So see, diffusion in liquids. Just I told you, gas A plus B, gas A plus B. Temperature P1 T1, temperature P2 T2. And because we are dealing molecular diffusion, we are not dealing pressure diffusion or temperature diffusion. So pressure temperature तो सेम ही होना है पक्का 100% केसेस में हमारे सिलेबस के अकॉर्डिंग. So if T1 T2 P1 P2 same, then clearly CT1 will be also equal to CT2. Why? Because P is CRT and C is what? C is P by RT. So CT1 is P1 by RT1. CT2 is P2 by RT2, and P1 P2 same, T1 T2 same. So clearly it is same. But when you are going to see same thing in liquid case, then beta, density of this side, density of this side is not same. Molecular weight of this side, average molecular weight of this side and this side, it is also not same. So if these are not same, then clearly, my dear students, both side, if you are going to write CT1 and CT2, then for this case beta, CT1 is also not equal to CT2. That's why we need some special attention for these type of cases. Is it crystal clear? एक बार फिर से सभी लोग लिखेंगे बेटा. Please write everyone crystal clear in comment section so that we can move forward बेटा. Everyone please write it बेटा. Can we proceed? चलो बहुत अच्छी बात है. So here I'm not going to derive, just directly see. First thing you have to see what is average concentration. Average concentration क्या होता है पहले आप ये देखोगे बेटा. Very good बेटा. Now just see what is average concentration. First thing, average molecular weight. You all know about average molecular weight from one subject, that was process calculation. That average molecular weight is nothing but summation of XI MI, where XI always mole fraction, never take mass fraction. So XI is mole fraction of ith component. XI is mole fraction of ith component. Mi is molecular weight of ith component. Mi is molecular weight of ith component. I hope everyone crystal clear. So if two components are there, then you can write like XAMA plus XBMB. Okay, and as you had seen, both side composition is are different. So this side mole fraction of A, if this is XA1, this side mole fraction if XA2, then clearly XA1 is also not equal to XA2 बेटा. XA1 भी आपका XA2 के बराबर नहीं है, ये भी बराबर नहीं. ये क्या है? ये है मोल फ्रैक्शन. दिस इज मोल फ्रैक्शन बेटा. So if XA1 is not equal to XA2, then clearly XB1 is also not equal to XB2. And clearly beta, in this case molecular weight of chamber 1 or average molecular weight of chamber 1 is not equal to average molecular weight of chamber 2. So you have to calculate when you are seeing liquid cases. Then first thing you have to calculate in examination, that is average molecular weight of these chambers. After calculating it beta, after calculating it, now you have to calculate CT1. What is CT1 here? This is nothing yaar. This is mole per meter cube. This is molar density yaar. This is molar density. So if we are going to divide this mass density, whose unit is kilogram per meter cube, with average molecular weight of that chamber, then it is going to convert it into molar density, and this molar density is concentration. That means we can write CT as rho by M average. We can write CT as rho by M average of that respective chamber. If you are writing for first one, then rho by M average of chamber 1. For second chamber, then rho 2 by MAV2. And CT1 is not equal to CT2. So in final formula, you will see one term CAV, average concentration. Maybe it is written like rho by M average average. रो बाई एम एवरेज का भी एवरेज इस तरह से भी शो होता है और ऐसा भी शो होता है. देन हाउ टू राइट इट? बहुत सारे बच्चे फॉर्मूला पढ़ लेते हैं जल्दी जल्दी बुक से या कहीं से देख के, और फिर वो खोलना जानते ही नहीं है कि यार इसको हम सॉल्व कैसे करेंगे. तो बहुत आसान है. दिस इज नथिंग यार. अरिथमेटिक मीन ऑफ एवरेज कंसंट्रेशन, और यू कैन से कंसंट्रेशन ऑफ चैम्बर 1 एंड चैम्बर 2. अरिथमेटिक मीन ऑफ कंसंट्रेशन ऑफ चैम्बर 1 एंड चैम्बर 2. ये अरिथमेटिक मीन है यार, और कुछ भी नहीं है. दिस इज अरिथमेटिक मीन. दिस इज अरिथमेटिक मीन. आई होप एवरीवन क्रिस्टल क्लियर यार. सभी बच्चा लोग को ये क्लियर होगा पूरी तरह से. बेटा 1 मिनट लाइन पे बने रहें. हेलो, या टेल मी. Right now I'm in live class. I will call you after just half an hour or 1 hour. Okay beta, is it crystal clear to all of you beta? Is it crystal clear my dear students? So how to write it? First you have to check what is the density molar, what is the mass density of this chamber, what is the mass density of this chamber. Then you have to divide with average molecular weight of that respective chamber. But maybe in examination they are directly going to give you molar density. No need to worry. No need to worry. If directly molar density is given, then what is the formula? What is the formula? Rho molar density plus of chamber 1, rho molar density of chamber 2 divided by 2. Very easy na? Very easy. Chalo, fantastic. So now you all know this was the mother equation. So validity is for liquid or gas. सबके लिए ये valid था, हमने आपको पहले ही बताया था. Now the change that here in final derivation I am going to do, I am going to write in place of this CA XA into C average. अरे भाई जिस चैम्बर का लिखना है उस चैम्बर का एवरेज कंसंट्रेशन देखो क्या है, और उस चैम्बर के मोल फ्रैक्शन से मल्टीप्लाई कर दो. तो ये आपको उस चैम्बर में क्या है कंसंट्रेशन आपको बता देगा. व्हाट इज द कंसंट्रेशन ऑफ A इन दैट चैम्बर? Ca1. CaV equals to Ca1. So in differential part, if I am writing C average into XA, that means nothing but I am writing Ca. हम इसे Ca की जगह पे क्या लिख रहे हैं? हम इस Ca की जगह लिख रहे हैं C average XA. I am writing in place of this C average XA. So very easy, very easy. बहुत ही ज्यादा आसान है ना यार. It is very easy. So now rho by M average, rho by M average, rho by M average. Oh my god, average का भी average. That means it is not going to change. It is going to, you are already written here. Average already taken by you. So you are not going to write this for any respective place. So I can write this out of this differential equation. So finally I got this one. Now we have to apply this equation. We can also apply this equation for liquid cases. So Na by A equals to Nxa by A minus Dab, Dxa by Dz. But it is now rho by M average Dxa by Dz. After applying, you will get two important cases, equimolar and B stagnant. For equimolar case, dAB by Z, Xa1 minus Xa2. But here rho by M average is also present. Here dAB by Z, rho by M average by XBLM, Xa1 minus Xa2. So already you had seen in previous derivations, derivation is little bit larger one, like 3 or 4 slides derivation. So you have to remember directly. Similar type of equation आपको इसे याद कर लेने का है. आपको इसे याद कर लेने का है. इस पे कैसा क्वेश्चन पूछेगा, डोंट वरी, जस्ट सी क्वेश्चन बेस्ड अपॉन दैट वन. In a water butanol mixture, butanol is diffusing at 21 degrees Celsius. Under unidirectional steady state condition, unidirectional means it is the case of B stagnant. ये B stagnant का केस हो गया. Through a 0.1 centimeter thick film of water, when the concentration of butanol at the opposite sides of the film are 3% and 1% butanol by mole, the diffusivity of butanol in water is this. Diffusivity value is given. Densities of 3% and 1% butanol solutions are at this temperature is taken as 0.97 and 99. Data molecular weight of butanol 74, water 18. Then the rate of diffusion of butanol is, butanol का क्या होगा rate of diffusion? 2 mark question. ऐसे 2 नंबर के क्वेश्चन आपसे पूछे जा सकते हैं. Similar type of questions already asked in gazette examination, and these are just formula based. इसमें कुछ extra आपको नहीं करना होता. ये सीधा formula based ही आपको एग्जाम में पूछेगा, because already a formula calculation will take time in calci. Okay, so that's why they are directly are going to give you formula based question. Only the thing that you have to see, be careful, please don't forget to check units. Like here, see, it is in centimeter square per second, and they are asking in meter. Here it is meter square. So just you have to careful about units. आपको यूनिट के बारे में खास ध्यान रखना है सभी बच्चा लोगों को. Okay, so just I extracted all datas. Okay, density given, so this is mass density given. Molecular weight, how to write? See, average molecular weight formula used by me. Maybe in examination, if they want to little bit extra things they can give you to save time, so हो सकता है वो डायरेक्टली आपको एवरेज मॉलिक्यूलर वेट दे दे. इससे भी ज्यादा अगर उनको करना होगा तो वो मास डेंसिटी के बजाय डायरेक्टली दे कैन गिव यू मोलर डेंसिटी. ओके, सो दिस इज द लॉन्गेस्ट दैट दे कैन गिव यू. So see, rho m average calculated, xblm xb2 minus xb1 upon ln of xb2 minus xb by xb1 calculated. Just put in this formula, got answer 6.28 into 10 raised to power minus 4. So we have to put 6.82 only here, because here written 10 raised to power minus 4 already. So formula based question, again you have to calculate, you have to solve this numerical homework. All questions you have to repractice बेटा. सारे के सारे questions आपको repractice करने हैं. Okay, clear to all of you? Now please tell बेटा, यहाँ तक कोई डाउट नहीं है सभी को? क्या हम आगे प्रोसीड कर सकते हैं? अभी आप कमेंट कर सकते हो. कमेंट सभी के पढ़ रहे हैं, फटाफट बोल दो यार. Can we proceed? If any doubt, then please ask me बेटा. Can we proceed, my dear students? No doubt. Very good. Now, first topic is little bit larger along with numericals, but the second and third topic, that is surface and self diffusion, very very easy. Just a minute topic, 1 minute topic, and asked in interviews as well, and that can be asked in gate examination and PSU's examination too. So what is surface diffusion? Just think about catalyst. You had seen active sites in catalyst. Suppose these are active sites I am showing here, and in all active sites A is there. सारे एक्टिव साइट पे ए बैठा हुआ है, तो ए क्या इधर उधर भाग पाएगा एक साइड से दूसरे साइड पे? नहीं, ए कांट go towards any other side. But if this is the case that A is here only and one more A suppose here, okay, and many sides are still vacant, so this A can jump from this side to this. अभी वो यहां था, अब वो यहां आके बैठ गया, यहां से हट गया, जंप करके यहां आके भी बैठ सकता है. दिस इज नोन एज सरफेस डिफ्यूजन. सरफेस पे जंप कर रहा है मेढक की तरह. फ्रॉग लीप एंड फ्रॉग मैकेनिज्म, मेढक की तरह कूद कूद के इधर उधर जा रहा है. दैट इज सरफेस डिफ्यूजन. वैकेंट साइट्स पे जो जा रहा है on the surface, this is known as beta surface diffusion. For flux calculation, nothing special. Surface concentration you have to use ds dz, and numericals rarely they can ask based upon this topic. The most important thing that they can ask you this one. See, सबसे ज्यादा इंपॉर्टेंट यहाँ पे क्या है? ये होपिंग और लीप फ्रॉग मैकेनिज्म. They can ask you, hopping or leapfrog mechanism is associated with which type of diffusion? And the answer is surface diffusion. So only this is most important from this topic that can be asked in your gate examination. And these are basics, point number 1 and point number 2. Just one more time, see, I'm reading. It is the transport of adsorbed molecules. Adsorb, surface पे जो adsorb हो गया है, adsorb molecules on a surface in the presence of a concentration gradient. सरफेस पे जो कंसंट्रेशन का ग्रेडियंट होगा, एक साइड ज्यादा बैठे हुआ है, एक साइड कम बैठा है, तो कम वाले साइड इधर से कूद कूद के उधर जाएगा सरफेस पे, साइड टू साइड. इफ द वैल्यू ऑफ फ्रैक्शनल कवरेज ऑफ सरफेस इज 1, मतलब पूरा का पूरा ही भरा हुआ है, हर जगह ए है तो हर जगह ए ही ए है, then no surface diffusion. But if less than 1, some of active sites remain vacant, surface diffusion takes place. This is also known as molecules migration. And migration phenomena of adsorbed molecules are also known as hopping or leapfrog mechanism. So only one thing that can be asked from this topic in your examination: hopping or leapfrog mechanism is associated with. Answer is surface diffusion, gate and PSU both. Now next is self diffusion. अब ये self diffusion क्या है? Self diffusion means if this is bit of water, H2O, then inside water clearly molecules are not stationary. Water is stationary. आपने बोतल में ये पानी रखा हुआ है, this water is stationary, but still the molecules of water is not stationary. And you can see by dropping some drop of ink there, you can see water is in not stationary. It is not stationary, moving zigzag इधर उधर इधर मूव करता रहेगा. So how this water is going to move inside water? That is diffusion of water in water, self diffusivity. And if you want to calculate it, very 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 difficult here. How you can just see one molecule of water and going to see it? It is very 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 difficult, statical, बहुत ही डिफिकल्ट हो जाएगा. तो हम क्या करते हैं वाटर में देखने के लिए? आई एम गोइंग टू टेक सम आइसोटोप ऑफ वाटर एंड नाउ गोइंग टू पुट इन द दैट वाटर, this water, isotope of water to this water. Now what I am going to see, how it is going to move there, how it is going to move there. Like suppose real case, take hydrogen. So isotope of hydrogen, protium, deuterium, tritium. Actually what is isotope? Atoms with the same number of protons but different number of neutrons are called isotope. Not important. Chemistry students important, but get chemical engineering not important. What is isotopes? They share almost the same chemical properties. This line is important, but differ in mass, therefore in physical and therefore in physical properties. So उनके केमिकल प्रॉपर्टीज लगभग सेम होते हैं. इसके वजह से हम सेल्फ डिफ्यूजिविटी के लिए ए का, इफ यू वांट टू कैलकुलेट द सेल्फ डिफ्यूजिविटी ऑफ ए, देन यू हैव टू टेक प्योर ए एंड नाउ you are going to fill you are going to drop some isotope of a there. So isotope is used to calculate self diffusive. Very important line, already asked in PSU examination. ये वाला आपका पूछा हुआ लाइन है, ठीक है. So this is self diffusive. Important points about it, just see here. I am reading one by one. The molecules of gas liquid continuously move from one point to another position when the temperature is more than 0 Kelvin. 0 Kelvin पे वो भी स्टेशनरी हो जाएगा. Okay, but 0 Kelvin से ज़्यादा है, they have their kinetic energy, तो system is stationary but molecules is still moving. So molecules of a gas or liquid continuously move from one position to another position. So the molecules in a mixture of uniform composition also diffuse, but the net rate of transport across any plane is zero. मतलब क्या, इधर से 20 उधर जाएगा तो 20 उधर से इधर को आ जाएगा, तो नेट ट्रांसफर कहीं से कुछ हो ही नहीं रहा है, because everywhere the same molecule is present. There is no concentration gradient, so net transport is zero. But still molecules are in movable, like convection current. Molecule are taking energy and now leaving their place and going to convey or transport energy to some other place, to some other molecule chal raha hai. So this is self diffusion. Here self diffusion coefficient is termed as self diffusivity. So only important thing here, a basic, and the thing that how you are going to calculate self diffusivity with the help of isotopes. This is only the question that again they can ask in a GATE examination. वो गेट एग्जामिनेशन में ऐसा पूछ सकते हैं, अदर एग्जामिनेशन में तो ये पूछा हुआ है. सो दिस इज इंपॉर्टेंट फॉर गेट. Just one mark question. Okay, I hope everyone crystal clear. Now next is non-Fickian diffusion. You had seen diffusion follows Fick's law, but maybe diffusion are not going to follow Fick's law even for gas case. Then what is Graham's law and what is diffusion and numericals? From Graham's law, numericals can be asked 1 mark or 2 mark, and they are very very easy. So what is non-Fickian diffusion? First I will tell you. Non-Fickian is also known as amolus diffusion. Amolus diffusion and Graham's law, then effusion. तो अभी ये 3 टॉपिक हम लोग देखने वाले हैं. नेक्स्ट, सो प्रीवियस वन क्रिस्टल क्लियर बेटा? एक बार फिर सभी लोग लिखेंगे, so that we can move forward towards non-Fickian, Graham's law and effusion. Okay, I make your syllabus according to last more than 35 plus years of question paper of GATE as well as of PSUs. Okay, so फटाफट बता दो बेटा, कोई डाउट नहीं है अभी तक, सब समझ में आ रहा है? अगेन यू हैव टू रीप्रैक्टिस ऑल न्यूमेरिकल्स बेटा, सारे न्यूमेरिकल्स को एक बार फिर से रीप्रैक्टिस जरूर करोगे. एंड हियर यू कांट किल अ सिंगल मिनट. कुछ भी अननेसेसरी टॉक में टाइम को हम लोग बर्बाद नहीं कर सकते हैं. सो तुरंत फटाफट बता दीजिए, कोई डाउट है? नहीं है तो जस्ट राइट क्रिस्टल क्लियर. Okay, and if anyone wants to join this crash course, PYQs course, then just feel free to connect me, WhatsApp call. Max discount offer is going on. Okay, number is I think एक पट्टी नीचे चल रही होगी, उस पर शो हो रहा होगा 9451707049. इसके अलावा कोई दूसरा नंबर हम यूज नहीं करते हैं. Now what is non-Fickian diffusion? Just try to concentrate, ध्यान से सुनना. बहुत बड़ा टॉपिक है बट आपको 1 मिनट के अंदर हम समझाएंगे. ओके, टॉपिक इज लार्ज वन बट आई कैन हैंडल इन लेस देन 1 मिनट और नियर बाय 1 मिनट. सो जस्ट ट्राई टू कंसंट्रेट बेटा. ओके, ट्राई टू कंसंट्रेट बेटा. Non-Fickian diffusion also known as anomalous diffusion. What is anomalous diffusion? One question in GATE examination. 2 terms you need to consider. One is MSD, one is elapsed time. What is MSD? MSD is mean square distance. It is a measure of deviation of a position of a particle with respect to a reference point over time. कोई एक रेफरेंस पॉइंट आपने ये वाला ले लिया, अब इसी जगह से कोई पार्टिकल कितनी दूरी पर, अभी यहाँ है तो ये डिस्टेंस हो गया, यहाँ है तो ये डिस्टेंस हो गया. यही एवरेज जो होता है, डेविएशन, कितना डेविएशन हो रहा है, दैट इज मीन स्क्वायर डिस्टेंस. Now I can't discuss in detailed manner how this formula come. Don't worry. not important right now. Just focus here. Elapsed time. It is simply the amount of time that process from the beginning of an event to its end. मतलब प्रोसेस शुरू से लेके अंत तक होने में टोटल समय कितना हुआ आपका पूरा प्रोसेस होने में, वो है elapsed time. Elapsed time is small t. This is sigma r square, mean square distance. This formula not important. Now, three types of cases. One is Fickian diffusion. One is what is Fickian, what is non-Fickian. Just see here, beta. This is one molecule, and it want to. This is final dest. ये भूल जाओ, ये छोड़ो, ये मत देखो. इधर इधर नया डायग्राम देखो, नया डायग्राम देखो, नया डायग्राम देखो. This is molecule, and this is the point where it want to reach. This is the place where this molecule wants to reach, and some other molecule also there. Some other molecule is also there. One molecule is moving in such a manner that in 1 second or in 2 seconds it is covering this distance. In next 2 seconds again it is covering same distance. In next 2 seconds again it is covering same distance. That means distance traveled by that respective component is not going to vary with time. अगर वो 1 सेकंड में 1 मीटर चलता है तो अगले 1 सेकंड में भी 1 ही मीटर चलेगा, उसके अगले 1 सेकंड में भी 1 ही मीटर चलेगा. दिस इज द मॉलिक्यूलर डेप्थ ऑफ फिक्स्ड लॉ ऑफ डिफ्यूजन. सो दिस इज Fickian diffusivity, my dear students. दिस इज Fickian diffusivity. ये क्या होता है? ये diffusivity, Fickian diffusivity. But two other types of cases. One is super diffusion and one is sub diffusion. अब ये सुपर डिफ्यूजन क्या होता है, सब डिफ्यूजन क्या होता है? If molecules traveling in first 2 seconds or 1 second or 5 seconds this distance, then in second 2 second more distance, in next 2 second again more distance than the previous one. मतलब जैसे जैसे आगे बढ़ रहा है इसके अंदर और ज्यादा उत्साह आ रहा है और तेज दौड़ने लग रहा है. ये दिस इज सुपर डिफ्यूजन. आगे बढ़ते बढ़ते इसकी स्पीड में बदलाव देखा जा रहा है. So this is known as super diffusion. But if initially more than with respect to time, it is going to travel less distance in the same time interval. That is subdiffusion. My dear student, this super diffusion or subdiffusion is comes under category of non-Fickian diffusion. I hope everyone crystal clear. Okay? Yeah, beta Shyam. I hope everyone crystal clear about what is super diffusion, what is subdiffusion. Already asked in many PSU examinations, and definitely if asked, then they can also ask in GATE examination. Topic is very very small. Interviews में भी बार के कई बार ये पूछा है. In BARC and NPCL interviews already asked what is non-Fickian or what is super or subdiffusion. Okay. Now, one beautiful law. Fickian diffusion described by Fick's law of diffusion. Here one law is there, that is power law. In power law, MSD is proportional to dt raised to power alpha. D is diffusivity, T is elapsed rate. The value of alpha is 1 in case of Fickian diffusion, but the value of alpha may be less than or greater than 1 in case of non-Fickian diffusion. See, this is the graph between MSD and T. This graph can also be asked in your examination and they can give you match the column. आपको match the column दे सकता है. They can ask you match the column. So my distant super diffusion, see, if this is the time interval, here I am taking, and this is the time interval here I am taking, then in this time interval, mean square distance is this one, but in this time interval, mean square distance is more in comparison to the previous one. So clearly this is the case of super diffusion. Similarly here beta, similarly here, initially the mean MSD is less, but after initially it is more, but after some time see it is now less than the previous one. So clearly it is subdiffusion. Or if it is like this straight line, then clearly every time MSD with respect to time are not going to vary directly proportional. That is Fickian diffusion. So I hope this graph is also crystal clear to all of you. बेटा एक बार फिर सभी लोग फटाफट बता दो क्या ये क्लियर है? कैन वी प्रोसीड? बहुत कम समय में आई होप हम ये आपको डिलीवर कर पा रहे हैं. टॉपिक्स को डिलीवर करने में बहुत इन सबको समय लगता है, बट आई होप आई एम एबल टू डिलीवर इन ऑप्टिमम टाइम इन सुपर मैनर बेटा. सो अगर क्लियर है तो एक बार लिख दो, फटाफट हम लोग आगे बढ़ जाते हैं. Is it crystal clear to all of you, my dear students? Can we proceed? Can we proceed, my dear students? No doubts. All clear na? No doubts. All clear. Can we proceed, beta? Okay, so 1 hour completed. Okay, very good. Now take 30-second rest and then we will start again. Fatafat revise that the topics that you learned today. Chalo. What is diffusion? What is diffusion? What is diffusion? What is diffusion? Also asked in interviews, and just a simple 1 mark question ask can be asked in GATE examination. Diffusion, the main thing, driving force is difference in concentration, but for effusion it is delta P. Effusion is happening in fluid mechanics. आपने fluid mechanics जो देखा था उसमें फ्यूजन बहुत आप देखोगे because of delta P, pressure difference के कारण. One more thing, infusion. Infusion is by solvent seed oil extraction. During solvent seed extraction, if something you are going to extract with the help of solvent, that is infusion. Flow through orifice you had seen in fluid mechanics. That is known as Sampson flow. तो आपसे पूछ सकता है Sampson flow क्या होता है? तो अगर किसी orifice से कुछ flow होके जा रहा है, that type of flow is known as Sampson flow. That is known as Sampson flow. Okay, large diameter than mean free path. Just one more case is there. Now see, two cases again. Whole dia can be less than mean free path, whole dia can be more than mean free path. If it is more, then this comes under category of effusion, and also it is not happening due to delta C, it is happening due to delta P. But if this is the case, whole dia is more, then this is comes under category of diffusion, and mostly here the things that you are going to see based upon delta C. Two cases already discussed in Knudsen law. Two diagrams, same type of diagram here also. So please see important points here. Effusion occurs when the size of aperture of the hole is smaller than the mean free path of the molecule. Effusion is the ability of a gas to travel through a small opening due to delta P. Diffusion happens when there are no holes or holes in the barrier. Effusion के लिए होल जरूरी है, डिफ्यूजन के लिए होल जरूरी नहीं है. Okay, during effusion particle move faster than diffusion because there are less or no collision between molecules. Effusion facilitated by pressure difference. Molecular diffusion occurs due to concentration difference. So only the important point that you have to see, you have to remember this one: effusion, pressure, diffusion, concentration, and this is Sampson flow. This is important. Okay, this is important. So this you have to remember only here. That can be asked, and this already you know. This can be asked in GATE examination, that the driving force for effusion is, then maybe you can see, you feel that time that it is concentration difference, but no, if they are writing effusion, then the driving force is pressure difference. Okay, आई होप सभी को क्लियर होगा. इससे ज़्यादा भी इस पर समय नहीं दे सकते. इन डिटेल्ड कोर्स थोड़ा और ज़्यादा इस पर समय देते हैं, बट अभी केवल आप उस पर फोकस करोगे जो दैट कैन बी आस्क्ड इन गेट एग्जामिनेशन. सो सैमसन फ्लो इट कैन बी आस्क्ड इन गेट एग्जामिनेशन, एंड प्रेशर डिफरेंसेस एसोसिएटेड विद इफ्यूजन इट कैन बी आस्क्ड इन गेट एग्जामिनेशन. दैट्स इट. इसके अलावा इसके बारे में कुछ भी याद नहीं रखने का है. नथिंग यू हैव टू रिमेंबर बेटा. ओके sir, like MO green slides, important topic beta. Here also many topics, the syllabus of mass transfer operation is much larger in comparison to MO. Okay, that's why here we can't write everything separately 1 2 3 4. Here already I deleted many slides. या बहुत सारे slides को हमने बीच में जो उसका डिटेल है जो समझाने के लिए एक्स्ट्रा टाइम डेरिवेशंस वगैरह है वो हमने इसमें ऑलरेडी कट कर दिया. लाइक इसके बाद से फिर 5 स्लाइड्स 6 स्लाइड्स आती हैं, फिर ये आता है मेन कोर्स में डिटेल्ड वाले में. बट यहाँ डायरेक्टली ऑलरेडी इट इज ग्रीन स्लाइड बेटा. द थिंग्स आर रनिंग इन ग्रीन स्लाइड्स. ओके, मिनिमम पॉसिबल दैट थिंग्स यू कैन डू. जितना आप कॉन्टैक्ट कर सकते हो, क्रैश कम फुल कोर्स, कंप्लीट थिंग्स विल बी देयर. ओके, और उसको कंप्रेस किया गया है जिससे कोई टॉपिक भी मिस ना हो. सो these are green slides, so you have to make your notes according to this. Okay. Only if you want to cut something, then the thing that I'm writing here, gate, only you can write from some topics what can be asked in gate examination. See, this is diffusion, this is Samson flow, this is diffusion, already discussed. So if you want to make green slide, so just you can write this about these three topics. देखो हमने यहाँ बना दिया. Okay, केवल इसे नोट कर लो. That's it. Okay, that's it. Okay. My dear student, as I told you, talk G earlier, just discuss about this subject, no other comments. Okay, everything if you want to know when course start, when course end, what is the schedules or how you are going to complete in what time, then just without feel free to call me 9451707049. Feel free to WhatsApp me. Okay, and don't worry if I started something, then definitely I have some plan and I am going according to that plan. ओके, बहुत सारे प्लान्स आपको बताए नहीं जाते हैं, आप थोड़ा पैनिक होते हो, डरते हो, फिर हटाते हो. हमें पता है कि चीज़ों को कैसे आगे लेके जाना है जिससे आपके लिए वह चीज़ें सबसे ज़्यादा बेनिफिशियल हो. ओके, सो फटाफट यहाँ आ जाएं वापस से. नेक्स्ट टॉपिक इज देयर, that is Graham's law of diffusion. Graham's law of diffusion. Only the important thing here, that is rate is proportional to 1 by root of molecular weight. And you know, when you are assuming ideal gas, P equals to nRT, P equals to n by VRT, P equals to rho m RT, rho m equals to P by RT. So my dear students, clearly here you can see, if we want to write rho m, so what is rho m? Rho m is rho by m average. So rho can be written as Pm average by RT. So I can write this m average in terms of density also. हम इसे density के फॉर्म में भी लिख सकते हैं, इसे हम density के फॉर्म में भी लिख सकते हैं. So only this you have to remember it. And this R is not radius, this R is rate. So rate of diffusion for some gas whose molecular weight is mw1, and if second is mw2, then what is the rate of that gas? So it is very easy, inversely proportional of their square root. Inversely proportional of their square root. Okay, see, beautiful numerical based upon previous one. बहुत आसान है. CO2 and oxygen gases are present at same temperature and pressure. Temperature and pressure must be same, because if they are not same, then they are also going to affect their respective rate. Okay, then you can't write mw instead of mw rho, you can't write. Now if CO2 passes through a small hole at a rate of 2 मीटर पर सेकेंड, मतलब ये आपका स्मॉल होल है, यहाँ से अगर CO2 पास कर रहा है 2 मीटर पर सेकेंड की रफ्तार से CO2 जा रहा है, अगर उसी स्मॉल होल से ऑक्सीजन को गुजरना हो सेम टेम्परेचर प्रेशर पे, तो उसकी स्पीड क्या होगी, यही आपका छोटा सा प्रश्न है. सो आर CO2 इज गिवन, molecular weight you can calculate, MO2 you can calculate, then you have to just calculate RO2. Very easy formula. Again, if you remember this formula, very easy to calculate. Here the answer is 2.34 meter per second. Why it is coming more? Because if molecular weight is less, then the respective speed is more. Because molecular weight less, that means density is less. Okay, is it clear to all of you? सब डिफ्यूजन मीनिंग डिफ्यूजन स्टेगनेंट होता है ना, स्लजिश होता है ना सर. बट हाँ, जैसे जैसे आगे बढ़ेगा श्रेयान, वैसे वैसे स्लजिश होता जाएगा, स्लो होता जाएगा. जैसे यहाँ से चढ़ा वो पार्टिकल अपने डेस्टिनेशन पे पहुंचने के लिए, तो जैसे जैसे आगे को बढ़ रहा है, ये थोड़ा थोड़ा स्लो होता जा रहा है. ऐसा हो क्यों रहा है? क्योंकि आगे की तरफ बढ़ने में कंसंट्रेशन का थोड़ा सा और बदलाव उसको फील हो रहा है. ओके, दैट इज सब डिफ्यूजन. ओके, very good, fantastic, mind blowing, super beta. Again, re-practice with your calci this beautiful numerical. Now today's next topic is fix second law and application. अभी हम लोग फिक्स के सेकंड लॉ को देखेंगे और इससे रिलेटेड हम लोग एप्लीकेशन को देखेंगे. ओके, सो बता दो सभी लोग, अभी तक जो भी पढ़ा सब क्लियर है? क्या हम आगे बढ़ सकते हैं? टेल मी बेटा. आई टुक वेरी लेस टाइम फॉर मेनी टॉपिक्स, बट आई होप able to clear, able to deliver in super manner. If yes, then please tell me in comment section. Then देखो फिक्स सेकंड लॉ ऑफ डिफ्यूजन फटाक से कंप्लीट कर देते हैं. आप में से बहुत सारे बच्चे तो फिक्स सेकंड लॉ ऑफ डिफ्यूजन का इक्वेशन भी सही से नहीं लिखे होगे अपने नोट्स में, देख लेना. पूरा इक्वेशन बहुत सारे बच्चे इसका जानते ही नहीं है. मोस्ट ऑफ द प्लेसेस इसका पूरा इक्वेशन पढ़ाया ही नहीं जाता है. क्या है पूरा इक्वेशन, अभी आपको शो करते हैं. फर्स्ट टेल मी क्लियर, एंड दैट इक्वेशन ऑल्सो यूज्ड फॉर मेनी PYQs. चल बहुत अच्छा. सो फिक्स सेकंड लॉ. Fixed second law, that means three dimensional. You are going to see things in three dimensional, but that equation is also applicable to two dimensional and one dimensional cases. Before that, one beautiful law you have to see, that is law of conservation of species for a stationary medium. Law of conservation of species for a stationary medium. The law is similar to law that you had seen in first law of thermodynamics. That was law of conservation of energy. Energy can neither be created nor be destroyed, only it can transform from one form to another form. Okay, so this is similar law, that is law of conservation of species, and this law plays an important role in the analysis of mass transfer problems. Now what is this law? Very easy यार, बहुत ही आसान सा law है. Actually we can't tell this law as law of conservation of mass only, because मास को उत्पन्न नहीं कर सकते, नष्ट नहीं कर सकते, वो अलग चीज है. यहाँ रेस्पेक्टिव स्पेसीज की बात करें, स्पेसीज को तो किसी सिस्टम में आप उत्पन्न कर सकते हो ना, एक स्पेसीज दूसरे स्पेसीज में बदल सकती है ना यार. That's why I'm writing law of conservation of species. Mass is still law of conservation of mass everywhere is there, but here I'm talking about respective species. Maybe left hand side 1 kg of that species is present, total mass is 10 kg. In right hand side still total mass is 10 kg, but that species may be now 3 kg. So how the things are going to change? These things are calculated based upon law of conservation of species. Law of conservation of species. Okay, so what is this law? See, very easy. Suppose you are taking some control volume and you want to check here how things are changed in this control volume. So my dear students, suppose A entered here 10 kg. Inside this system, inside this system, suppose my dear students, A generated. How generated, sir? Some chemical reaction can be there now. Maybe some chemical reaction there. Some chemical reaction may be there. And some B is also going along with this A, and that B is going to convert it into A. वो B हो सकता है A में घुस convert हो जा रहा हो यार. So maybe A is going to generate here ना. So suppose generation is 2 kg, and from here you are suppose getting only and only 11 kg. क्या बता सकते हो यहाँ पे स्टडी स्टेट में कितना आना चाहिए? Can you tell me in a steady state, at a steady state, what is the amount that exited toward this control volume? कितना kg होना चाहिए? Based upon this beautiful example, 10 kg, 2 kg. 10 kg enter from outside and 2 kg internally generated. That is with the help of chemical reaction. So कितना होना चाहिए? बता सकते हो क्या आप लोग बेटा? आराम से देखो और बताओ, मैं फटाफट बताएं. Tell me everyone. Don't know. My dear student, 10 plus 2, 12 will be there now. But why it is 11? Because rate of accumulation here is 1 kg per second. ये system 1 kg per second के हिसाब से अपने अंदर accumulate भी कर ले रहा है. So how you are going to write it? 10 plus 2 minus 11 equals to 1. See this equation. In plus generation minus out बराबर rate of accumulation within that control volume. Okay, and species generation, this term only and only applicable when chemical reaction is there. If no chemical reaction is there in that system, then this is 0. If no chemical reaction, then generation is 0. If no chemical reaction, MA generation is 0. Tell me beta, this equation is clear to all of you? Can we proceed? Just write CC. प्रांजल बेटा अभी क्लियर हो गया तो एक बार क्रिस्टल क्लियर लिख दे बेटा. Is it crystal clear to all of you? After lecture, PDF of today's lecture will be available for paid members in Gate Chemic Learning App. Chalo. So, for control volume, what is law of conservation of species? The rate at which the mass of some species enters a control volume plus the rate at which species mass is generated within the control volume, this term, minus the rate at which this species mass leaves the control volume, minus this one, must equal the rate of increase of species mass stored within the control volume, this one. I hope everyone crystal clear. Now what is fixed second law? अब हम लोग फिक्स सेकंड लॉ की इक्वेशन को देखने वाले हैं. That is also known as general diffusion equation. Here I am not going to derive it. Derivation is present in full course, complete course. Here directly I will give you that final equation and how to use that equation. In examination you are not going to derive it. So clearly if I am going to derive, still you have to remember it. Okay, so for extra feeling, if you want derivation, you can just follow my complete course. फिक्स सेकेंड लॉ ऑफ डिफ्यूजन और फिक्स सेकेंड लॉ इक्वेशन और जनरल डिफ्यूजन इक्वेशन क्या होता है, ये उसके जानने के लिए पहले ये थोड़ा सा आपको बेसिक जानना पड़ेगा. बिफोर दैट आई वांट टू डिस्कस सम बेसिक बिफोर फाइनल एक्सप्रेशंस. ये फाइनल एक्सप्रेशंस बताने के पहले कुछ बेसिक जान लो. इन दिस डेरिवेशन one assumption is there, that is a stationary medium approximation holds. What is the meaning of a stationary medium? That is, mass transfer may be approximated as occurring only by diffusion between because advection is negligible. Here we are not going to consider advection. यहाँ advection की बात नहीं कर रहे जो velocity के साथ associated होता है. That's why we are telling it as a assumption is stationary medium approximation, because maybe in few cases some advection may also be present. Okay, so I hope assumption is crystal clear to all of you. बोलो सभी को clear है? चलो. Now, what is n dot a? N dot a or capital N dot a both are rate of generation of species. If I'm writing a small, then this is in terms of mass. This is mass flow rate. Capital N, this is molar flow rate. Nothing special. And because this is generation, so how much generate per unit volume of that system? Just like you had seen in case of heat transfer operation Q dot gen. कितना जनरेट हो रहा है जूल पर मीटर क्यूब, इसी यूनिट में तो आता था. हेट ऑफ जनरेशन पर यूनिट वॉल्यूम ऑफ दैट रेस्पेक्टिव केस, respective system. Now see in 3-dimensional, from this side this is coming, this flux is coming, this out. From y direction this is coming, this is out. From z this is coming, this is out. Cartesian coordinate. And after derivation, what is the final formula that you need to remember? This one. ये remember करना, you need to remember it. And in most of the books you will be able to find this. Actually रो के फॉर्म में तो बहुत सारे में है भी नहीं, और है भी तो ये वाला टर्म जनरेशन वाला आपको बहुत ज़्यादा स्टैंडर्ड बुक अगर देखोगे रिचर्डसन कुल्सन टाइप की, देन यू कैन फाइंड इट. ओके, सो फॉर्मूला इज वेरी वेरी इजी, डेरिवेशन इज लार्ज वन. सो जस्ट लाइक Fourier second law of heat transfer operation, del square t plus q dot gen by k equals to 1 by alpha dot t by dot t. This t is temperature, this t is time. Similar to this, k is thermal conductivity, here dAV. N dot A, here Q dot gen. Here rho A, here T. Okay. Sir, always rho A. Sir, we know CA. Don't worry, write CA here. Then this is capital N. Then this is also capital C. Nothing to worry. Concentration form में ऐसे भी आप लिख सकते हो. Okay, so this written in terms of mass. ये mass के form में, molar form में नहीं है. In terms of molar, if you want to write, no need to worry. See, delta CA plus N dot A by dAV equals to 1 by dAV dU CA by dZ. This term will be 0 if no chemical reaction. अगर केमिकल रिएक्शन नहीं हो रहा है और वह रेस्पेक्टिव स्पेसीज ए वहां पे जनरेट नहीं हो रहा है तो दूसरा टर्म 0 हो जाएगा. In most of the books, they are just dealing no chemical reaction case. Okay, but this is the complete equation, because maybe some chemical reaction is also going to occur, maybe some A is also going to generate there. बोलो सभी को clear है ये ना? No doubts? Just tell me one more time, beta. No doubt. Then how to write this? Del square dou 2 by dou x square, dou 2 by dou y square, dou 2 by dou z square. If rho is here, rho a, rho a, rho a. If CA here, CA, CA, CA. So very very easy, very very easy to expand this. एक बार सभी लोग बोल दो बेटा, क्लियर है क्या? क्या हम आगे बढ़ जाएं? You have to remember these equations too बेटा, फटाफट बता दो. Clear? या बेटा हीट वाले इक्वेशन से एनालॉगस है, बिल्कुल एनालॉगस है. बहुत सारे लोगों का लेक्चर में देखा यूट्यूब पे, कहते हैं उसमें ये इसमें ये अंतर है कि इसमें जनरेशन टर्म होता ही नहीं है. अरे कैसे नहीं होता है भाई, यहाँ भी होता है. सो टोटली एनालॉगस इन नेचर. बट इफ नो केमिकल रिएक्शन इज देयर, सो मे बी यू आर हैव नो नीड टू राइट दिस टर्म. सो ये उसका शॉर्ट फॉर्म है, ये इसका शॉर्ट फॉर्म है. इफ नो जनरेशन इज देयर, देन दिस इज द इक्वेशन. ओके, क्लियर बेटा? Can we proceed? Okay. In cylindrical coordinates, this is the whole equation, and rarely they can ask the complete equation once in 20 or 25 years. ऐसा 20 साल में एक बार ही देखा गया है कि ऐसा बड़ा इक्वेशन आपसे पूछा गया हो किसी सब्जेक्ट का. ओके, सो पूरे इक्वेशन को अभी तो याद हम करने के लिए लास्ट थोड़े समय में नहीं कहेंगे. बट इफ सम स्टूडेंट इज नाउ गोइंग टू सी दिस लेक्चर इन फ्यूचर, एंड at least 5, 6 or 7 months left for gate examination, or 8 months left for that gate examination, then they can also remember this complete equation. Okay, but the term that you need to remember, आपको ये पार्ट याद रखना है, फर्स्ट आर कोऑर्डिनेट. ओके, इतना तो एटलीस्ट याद रखना है. In cylindrical coordinate, here DAB, DAB, DAB is present. I am writing by dividing DAB here. So don't see this one. ये अभी मत देखो, ये देखो जो हमने हैंड रिटन दिया है. यहाँ पे जो हैंड रिटन वाला है वो देखोगे. ठीक है, ये वाला देखो, ये वाला मत देखना, ये वाला मत देखना. ओके. अल्फा बराबर DAB नहीं होता बेटा. अल्फा इज थर्मल डिफ्यूजिविटी, DAB इज मास डिफ्यूजिविटी. ओके, this is alpha, this is DAB. And logos in nature. This term is also there, but here alpha and K different. But here DAB, DAB same. So you need to remember at least this part, this and this. इतना आपको इसका मिनिमम याद रखना है. एंड इफ यू कैन रिमेंबर दिस वन, दिस इज ऑल्सो ईजी एक्चुअली. आपने हीट में पढ़ाई होगा तो सिमिलर टाइप का है, कुछ अलग नहीं है. फोरियर्स लॉ ऑफ हीट कंडक्शन को जैसे एक्सपेंड करते हो, सो चाहो तो रिमेंबर कर सकते हो. अगर हम देखते 2 महीने 3 महीने के दौरान तो हम तो रिमेंबर कर लेते हैं. बट अगर आपकी दिमाग की कैपेसिटी थोड़ी कम है तो इसको भी कर सकते हो. ओके, नाउ if one dimensional steady state, no chemical reaction, this is going to become 0. One dimensional, second term going to become 0. Steady state, dot term is going to become 0. Then only the thing that remained, this equals to 0. Very very easy now, very very easy. You can also write in terms of XA. So in place of CA, directly you can write XA, because XA, C is total concentration. Come outside, 0 by C will be 0. So दोनों फॉर्म में आप इसे ऐसे लिख के एक्सपेंड करके फिर आप न्यूमेरिकल्स को सॉल्व कर सकते हो. ओके, शाजिद बेटा, यहाँ पे हम लोग एक एक पॉइंट्स को अलग से लिख नहीं सकते, आपको ये नोट्स में बनाना पड़ेगा, थोड़ी मेहनत ज़्यादा करनी पड़ेगी, मास ट्रांसफर ऑपरेशन बड़ा सब्जेक्ट है इसलिए। तो आप बस कंसिडर करो जो हम आपको बता रहे हैं, जितना आप उसमें से रख सकते हो, जो इम्पोर्टेंट हम बता रहे हैं बस वो आप नोट करते चलो। जैसे काट सिलेंड्रिकल बोला, ये नोट कर लिया, फिर यह लिख करके यह नोट कर लिया। दिस इज ग्रीन स्लाइड बेटा। ओके, क्योंकि यहाँ डेरिवेशन आपको नहीं ना कराया, यही आपका डिटेल कोर्स होता तो सिलेंड्रिकल वाला भी डिराइव करा देते, स्पेयर वाला भी डिराइव करा देते, कार्टेशियन वाला भी डिराइव करा देते। ओके, बट यहाँ पे आपको सीधे दे रहे हैं, तो ऑलरेडी दिस इज फाइनल इक्वेशन, दैट इज ग्रीन स्लाइड। सो जो इंपॉर्टेंट है वो आपको बता रहे हैं यहाँ पे। ओके बेटा शाजिद, step by step I will provide you PDF, so you can also see that PDF for revision। अगर आप नोट्स नहीं भी बना रहे हो so PDF को देख करके भी पढ़ाई कर सकते हो। बस आपको करना क्या है, न्यूमेरिकल्स री-प्रैक्टिस करना है। You can also preparing just by seeing PDF files that I am going to share in Gate Chemic Learning App, and along with that just solve questions, because numericals are most important part for any big subject. 2 mark question mostly in Gate examination, numericals। Okay, सो द इम्पॉर्टेंट थिंग इज न्यूमेरिकल थ्योरी। जो भी चीज़ें हैं, इक्वेशन कौन से याद करने हैं, सारे इक्वेशन जो भी दे रहे हैं, इफ डेरिवेशन इज लार्ज देन यू नीड टू रिमेंबर। एंड मोस्ट इंपॉर्टेंट एप्लीकेशन दैट इज न्यूमेरिकल्स। आपको न्यूमेरिकल्स को प्रैक्टिस करना है, इसलिए हम कह रहे हैं री प्रैक्टिस री प्रैक्टिस री प्रैक्टिस न्यूमेरिकल। ओके, क्लियर बेटा। Similarly, see for spherical coordinate, this is a complete equation, but no need to see complete equation again, only the term that need to remember. See analogous in nature, here r present, here r square, that's it. So very very easy to remember, very very easy to remember। Okay, this n is our previous n dot a। okay, ये वही n dot a ही है, अलग नोटेशन मत समझना, ये n dot a। so this is a spherical coordinate। you can also make notes after this lecture by seeing PDF files along with your revision। PDF फाइल को देख के फिर से रिवाइज करके थोड़ा 1 घंटे 2 घंटे दे करके आप नोट्स को भी बना सकते हो, ऐसा भी कर सकते हो कि रिवीजन भी हो जाएगा while solving numericals। see PDF files, right, and then once reach numerical then solve that numerical। okay beta, now application of fixed second law। अब हम इसको अप्लाई कर रहे हैं कुछ और केसेस पे। like I told you, for a steady state no chemical reaction one dimensional, okay, and Cartesian coordinate, written CA is a function of x only। in examination they can ask you numericals, or just they can ask you this concentration distribution equation। आपसे वो concentration distribution का equation भी पूछ सकते हैं। okay, तो इसे कैसे solve करेंगे? just wait, I have to check how much slides left in today's lecture। okay, we will able to complete I think approximately 2 hour lecture। कितना समय बचा हुआ है? हाफ एन आवर इज स्टिल लेफ्ट। ओके, so steady state no chemical reaction one dimensional, Ca is a function of x only। so if Ca is a function of x only, see in this beautiful equation, this is going to become 0, this is going to become 0, no chemical reaction, this is also going to become 0, steady state this is also going to become 0, only this term will be left, dou 2 Ca upon dou x2 is equals to 0। by solving you are going to differentiate one time, so it will come dou Ca by dou x is equals to C1। one more time differentiation, Ca is equals to C1 x plus C2। now put boundary condition and obtain the constant value C1 and C2। see here, so after putting boundary condition, after obtaining it you will get this equation। initially this was Ca equals to a x plus b, I am writing instead of C1 C2 ab। ओके, सो लीनियर रिलेशन, लीनियर रिलेशन ऐसे में कैसा आता है, लीनियर ग्राफ आता है, ये आपको बताना चाहते थे। एंड ए एंड बी आर कांस्टेंट्स दैट यू कैन फाइंड विद द हेल्प ऑफ बाउंड्री कंडीशंस। आफ्टर पुटिंग बाउंड्री कंडीशंस इसकी वैल्यू Ca_S2 माइनस Ca_S1 बाई एल आएगा और बी की Ca_S1 आएगा। सिमिलरली इफ दे आर आस्किंग इन टर्म्स ऑफ मोल फ्रैक्शन देन dou 2x by dou x2 equals to 0। see same thing here also comes, x equals C1 x plus C2 A and B constant, like C1, C2 also constant. Here see boundary condition at x equals to 0, like this is the case. इधर से इधर को डिफ्यूजन हो रहा है. So at x equals to 0, this is x equals to 0, this is x equals to L. ये x बराबर 0 पर है बेटा, ये x बराबर L पर है. ओके, x इक्वल्स टू 0, ये x इक्वल्स टू L. सो 0 पे मोल फ्रैक्शन XaS1 है, L पे मोल फ्रैक्शन XaX2. देन जस्ट पुट these boundary conditions, you will get C2 as XaS1, C1 as XaS2 minus XaS1 by L. ये नीचे का दिख नहीं रहा होगा, ये बटा L लिखा है पूरे के. After that, just put C1, C2 here, you will get this one. So no need to remember, no need to remember. ये लिखना नहीं है, लिखना नहीं है, ना 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 ना, ये रिमेंबर नहीं करना. You know how to deal it, you know how to deal it. आपको डीलिंग पता है, तो ये आपको डीलिंग सीखनी है इसकी, how to deal, how to do this derivation. So no need to remember. That's why here I'm not writing to remember or you to remember it. I'm not writing remember it. हम आपको remember it नहीं लिख रहे हैं. ओके, क्लियर बेटा? एक बार सभी लोग क्रिस्टल क्लियर लिख दो, फटाफट लिखो बेटा, जल्दी से लिख दो फटाफट, so that we can move forward. Any doubt then you can ask me. दिमाग तो दिमाग में है ना, उड़ तो नहीं गया ना? थोड़ी मेहनत करनी पड़ेगी बेटा, ऐसे ही नहीं आप 15,000 की भीड़ में टॉप 100 में आ जाओगे, ध्यान रखना. थोड़ी सी मेहनत करनी पड़ेगी, ठीक है? तभी 14,900 या कह लो मोर देन 99% बच्चों को तभी आप पीछे ढकेल पाओगे, टॉप 1% में अगर आना चाहते हो तो. वेरी गुड श्यान बेटा. और मेहनत करनी पड़ेगी बिल्कुल. सब कुछ ABCD नहीं होता है, थोड़ा सा बड़ा सब्जेक्ट मास ट्रांसफर ऐसा सब्जेक्ट है, बड़े बड़े लोग उसको छोड़ छोड़ के पूरा टॉपिक कवर नहीं कर पाते. बट यहाँ पे क्रैश कोर्स की यह खासियत है या खूबसूरती है कि सारे टॉपिक्स को बहुत ही कम समय में हम आपका कवर करेंगे, कुछ भी छोड़ नहीं रहे. बस आपको अपने साइड से क्या करना है, बहुत सारे, इसलिए हमने सब पे न्यूमेरिकल भी आपके यहाँ लगा दिए हैं, ताकि हर एक टॉपिक न्यूमेरिकल्स के साथ क्लियर हो जाए. आपको बस होमवर्क में रिवीजन करना है और हर एक न्यूमेरिकल्स को रीप्रैक्टिस करना है. इन होमवर्क यू हैव टू रिवाइज इट अगेन. एंड इफ यू कैन, अगर हम रहते तो PDF फाइल से फिर लेक्चर के एंड होते ही तुरंत उसी रात में PDF फाइल से नोट करना स्टार्ट करते और सेम रात में ही सारे के सारे न्यूमेरिकल्स को भी सॉल्व कर देते, अगर हम आपकी जगह रहते. ठीक है, बट आप लोग जल्दी थक जाते हो, जाने क्या ही एनर्जी लेके आते हो, हैं? तो अगर ऐसी डेडिकेशन दिखाओगे यार तो आपका भी रैंक फटाफट आ जाएगा. 2 से 2.5 महीने जो बचे उसमें रैंक ला दोगे यार. ओके, क्लियर? चलो आगे बढ़ते हैं. Flux equation, how to write, same thing, nothing special in that flux equation. In that flux equation, just do xa by dou x. From here it is C1 and C1 is XaS2 minus XaS1 upon L. So just you are going to put here, nothing special, nothing special. This is same equation, dAB by Z CA1 minus CA2. So nothing to remember here. यहाँ रिमेंबर करने वाली क्या बात है भाई, कुछ रिमेंबर करने वाली बात है? ये इक्वेशन पढ़े नहीं हो, हैं? C के फॉर्म में होता है तो DA by Z लिखते हो, PA के फॉर्म में होता है तो DAB by RTZ लिखते हो, तो क्या कुछ नया है क्या यहाँ पे? और NA कैप NA by A होता है. So if they are asking NA, then A will also be here. So कुछ है क्या यहाँ? कुछ भी नया नहीं है, हाँ? कुछ भी नया नहीं है, तो नोट भी नहीं करना है और आपको रिमेंबर भी नहीं करना है. नो नीड टू रिमेंबर, इट्स द सेम equation that already you had seen. Now the new thing that here I am going to share with you beta, this equation can be written as CA1 minus CA2 upon L by DABA. You remember delta T by L by KA in heat transfer operation. This was resistance na. So my dear student, this is also diffusional resistance. One different type of problem that can be asked, what is the value of diffusional resistance here? So very easy. See, all 3 coordinates I had taken here, my dear students, and written respective XA formula. No need to remember this or this. The thing that you need to remember that can be asked in exam and interviews. For this geometry, this will come linear. See, in all these case, generation will be zero. In all these three cases, generation is zero. इस सारे के सारे जो तीन केस आप देख रहे हो, तीनों में ही बेटा जनरेशन क्या है? जनरेशन इज जीरो. So for flat plate, it is coming linear. For this geometry, the profile of concentration or mole fraction, both logarithmic. For this case, it is coming hyperbolic. These all I derived in my complete course, but अभी यहाँ derivation की जरूरत नहीं है. Okay, so directly you can remember it. For flat, linear. For cylindrical, logarithmic. For spherical, hyperbolic. And these equations, please don't try to remember. ये रिमेंबर नहीं करना है. ओनली कंक्लूजन इज इंपॉर्टेंट फॉर अपकमिंग गेट एग्जामिनेशन. केवल और केवल यहाँ का जो कंक्लूजन है वही आपके लिए इंपॉर्टेंट है बेटा. What is the resistance? Diffusion resistance L by dVA. Already you had seen. And these in similar manner you can see just like in heat transfer operation. ये हीट ट्रांसफर ऑपरेशन की तरह ही आप यहाँ पे भी लिख सकते हो, देख सकते हो. आफ्टर राइटिंग जस्ट दैट ड्राइविंग फोर्स, everything that is present in denominator is your resistance. And out of these three, this is most important. So only you have to remember this for your upcoming gate examination. L by D B A D A B A L by D A. In short, you can tell. So one more question. If Na और Na dot is also there, अगर यहाँ generation हो जाए बेटा, if I am writing, if my dear students, I am writing that generation is not equal to zero, no need to worry. For these all cases बेटा, सारे ही cases में profile अब parabolic आएगी. In all cases the profile will be parabolic. So very easy. When a generation term is there, if Na or Na dot is there, then and with a steady state, then all profile will be parabolic. If generation is not there and steady state, then linear, logarithmic and hyperbolic. ओके बेटा, सभी को क्लियर है क्या? सभी को क्लियर है क्या? फटाफट बता दो भाई, फटाफट बता दो, आगे बढ़ जाते हैं. बिल्कुल विराट कोहली की तरह फॉर्म में आ जाओ भाई. सचिन तेंदुलकर जैसे पहले फॉर्म में रहता था और विराट कोहली जैसे अभी फॉर्म में चल रहा है. बोलो भाई, कैन वी प्रोसीड? हम हमेशा फॉर्म में है भाई, आप भी फॉर्म में आ जाओ. आप फॉर्म में आ जाओ बेटा. सभी लोग पूरे फॉर्म में रहो, खतरनाक वाला. ठीक है? ओके. Now see profiles. How the profile looks. Linear, this is the linear. Parabolic, this is parabolic. In examination many problems they can ask like with the diagrams. बहुत सारे क्वेश्चन पूछते हैं, आईपीसी, मास, हीट ट्रांसफर, डायग्राम, ग्राफ क्वेश्चंस. So this is the shape for parabolic one. This is linear everyone know. Logarithmic, hyperbola nearly same type, but in hyperbola curve is little bit more curve here, curvy nature. Here it is curve plus a straight line mixture. This is logarithmic. This is logarithmic beta. Is this clear beta? Is it clear? Is it clear? Sir, will they ask analogous question in gate? सेम टू सेम बेटा, डिट्टो आपसे कहीं से भी क्वेश्चन उठा सकते हैं जितने आपको इस स्लाइड में दे रहे हैं ना. एज आई टोल्ड यू अर्लियर, the things that I am going to cover in crash course that can give you rank 1, it's my open challenge. अगर नहीं ऐसा होता है, लाइफ टाइम के लिए पढ़ाना इस गेट के बच्चों को, इस गेट के लाइन को हम छोड़ देंगे अगर हमारे क्रैश कोर्स से रैंक 1 के लायक नंबर ना आए तो. इफ यू आर नॉट गोइंग टू सी रैंक 1 मार्क्स फ्रॉम जस्ट माई क्रैश कोर्स, देन आई विल लेफ्ट दिस फील्ड गेट. ओके, clear to all of you beta? So I am not confident, extra confident. This is not overconfident. This is totally I am confident. I am 100% confident. Not even 99.9999999. It's 100% confident. 100%. इससे नीचे आप परसेंटेज नहीं ले जा सकते हो, ठीक है। सो जस्ट यू हैव टू फॉलो कंप्लीट क्रैश कोर्स टॉपिक्स, ओके। चलो, सो ये प्रोफाइल क्लियर हो गया, तो आगे बढ़ते हैं। दिस इज जस्ट एक्स्ट्रा प्रैक्टिस क्वेश्चन एज प्रैक्टिस क्वेश्चन नंबर 29. जस्ट रीड इट इफ यू कैन, एंड इफ यू वांट टू लीव, लाइक छोटा दिमाग अगर आपका है, नहीं हैंडल कर पा रहे हो ज़्यादा न्यूमेरिकल, तो आप लीव कर सकते हो, इसलिए हम उस पर एक्स्ट्रा प्रैक्टिस लिख दे रहे हैं. इफ आई एम नॉट राइटिंग एक्स्ट्रा प्रैक्टिस, दैट मीन्स you must going to you must handle that question, you must solve that question. If I'm writing extra practice, that means if chota dimag, then leave it. If powerful dimag, then you can also extra practice, you give extra time to that numerical, okay. Along with this diagram, very very beautiful problem. Solution also, यहाँ solution भी आपको total दे दे रहे हैं, जिससे कोई भी पंगा ना हो आपके साथ. ओके, सो सॉल्यूशन ऑफ फिक्स सेकंड लॉ. अब हम इसके सॉल्यूशन के बारे में बातें करेंगे, ओके. इज इट क्लियर टू ऑल ऑफ यू? इज इट क्रिस्टल क्लियर? मिस्टर टॉर्क जी, आप बहुत परेशान हो यार. टॉर्क, डोंट वरी बेटा, डोंट वरी, जस्ट फोकस हियर, ओके. टॉर्क, एनी डाउट व्हेन द सिलेबस ऑफ एनीथिंग इज गोइंग टू एंड, जस्ट कॉल मी, ओके. जस्ट हियर. अगर आप पूरी तरह सब्जेक्ट पे नहीं फोकस करोगे ना, जितनी चीजें पढ़ा रहे हैं उड़ जाएंगी, नहीं समझ पाओगे, भूल जाओगे. सो दिमाग को थोड़ा स्टेबल रखो. अभी एमटीओ चल रहा है, ये डिफ्यूजन चल रहा है, कुछ और आपके दिमाग में आ कैसे जा रहा है यार, हैं? इतने परेशान जो रहता है ना, उसकी रैंक आ ही नहीं पाती है. परेशान जो एक्स्ट्रा परेशान रहता है, नहीं रैंक ला पाता है. जब कह रहे हैं जस्ट फोकस ऑन लेक्चर, फोकस ऑन लेक्चर, देन व्हाई यू आर राइटिंग द कमेंट दैट आई टोल्ड यू नॉट टू राइट, ओके. इस तरह का प्रश्न कब क्या स्टार्ट होगा, कब खत्म होगा, किस तरह चलेगा, यू कैन कॉल मी बेटा, ओके. आई एम टेलिंग यू ना, आफ्टर लेक्चर कॉल कर लो हमें, अगर कोई भी आपको डाउट है तो, ओके. सो क्लियर. Solution, here I'm not going to do complete solution, as I already told you, crash course, but I'm going to deal this topic in such a manner so that if anything is going to ask in gate examination, you will be able to handle it with numericals. So ध्यान से देखेंगे, फोकस करेंगे. Solution of fixed second law of diffusion. This is your fixed second law of diffusion, and the most general form of this equation, this fixed second law equation, is this equation. When a generation is 0, if not 0, oh my god, solution is very very difficult one, okay. Solution is very very difficult, complete solution is very very difficult one. So whenever they are going to ask, generation term will not be present there. If nothing mentioned in your problem, so you are going to use this general form, easier form, okay. Is it clear to all of you? Is it crystal clear beta? Walid, Shan, Tork, Pranjal ji, Shan, Rakesh and everyone. Chalo. So dou C, dou 2 CA by dou X2 equals to 1 by DAB dou CA by dou T. I can write CA as just C here, ताकि छोटा सा दिखाई दे यहाँ पे, and DAB at just like a D, okay. This DAB I am writing this side, huh? So D dou 2 C by dou X2. I hope everyone crystal clear. क्लियर बेटा? चलो, अब इसका सॉल्यूशन कैसा आता है, ये इसका सॉल्यूशन है. सर इक्वेशन इज इंपॉर्टेंट, या बेटा इक्वेशन इज इंपॉर्टेंट वन, बिकॉज इन PYQs यू कैन फाइंड न्यूमेरिकल्स फ्रॉम दिस टॉपिक. इससे पूछा हुआ प्रश्न है आपके PYQ में, हीट से भी पूछ सकता है और मास से भी पूछ सकता है. एंड दे कैन ऑल्सो आस्क जस्ट इक्वेशन that which one of the following is the solution of fixed second law of diffusion, and in 4 options you can find this as one option. ये आपको एक ऑप्शन मिलेगा. तो इसे सीधे रट्टा मारने के अलावा कुछ भी आपके पास नहीं है ऑप्शन, क्योंकि ये बहुत डिफिकल्ट इसका सॉल्यूशन हमने कराया है और बहुत लंबा चौड़ा कराया है, ठीक है. तो सॉल्यूशन आप याद नहीं कर पाओगे, ना कर पाओगे एग्जाम में. सो डायरेक्टली यू नीड टू रिमेंबर, डायरेक्टली यू नीड टू रिमेंबर, यू नीड टू रिमेंबर इट, ओके बेटा. You need to remember it. Cs minus Cx upon Ch minus C naught equals to error function x by 2 root dt. Now the most important part of this equation, this part, from where numericals already asked in gate examination, from heat transfer also, their heat transfer question is there. dt. If x is the distance from which a diffusion occurred. See one beautiful example. कार्ब्यूराइजेशन ऑफ स्टील, स्टील के अंदर में कार्बन को मिला रहे हैं, ठीक है, कैसे मिला रहे हैं? सी दिस इज द स्टील, दिस इज द कोऑर्डिनेट c concentration and x distance, and initially suppose in complete steel maybe c naught is 0, maybe it is 0, maybe not equal to 0. So at any x, here, anywhere, same concentration. That means still we are not going to add carbon from our side. अभी हम अपने साइड से कार्बन को ऐड नहीं कर रहे. ट्रांजिएंट स्टेट वाले इक्वेशन से रिलेट कर सकते हैं क्या? नहीं कर सकते हैं आप, ठीक है, नहीं कर सकते हैं आप सेमी इनफाइनाइट प्लेन के जो प्रश्न आते हैं, कुछ प्रश्न आते हैं जो सेमी इनफाइनाइट के, उसके साथ इसका रिलेशन आप दे सकते हो, ठीक है, क्योंकि उसमें एक्सपोनेंशियल टर्म आता था बेटा, और यहाँ आपका ये एरर फंक्शन है. हम ये एरर फंक्शन भी इस क्रैश कोर्स में आपको बताएंगे, फुल कोर्स में तो बताते भी हैं, यहाँ भी कुछ स्लाइड्स हमने ऐड ऐसे की है कि ऑप्टिमम टाइम में आपको एरर फंक्शन की पूरी फीलिंग दे देंगे आपको, तो बिल्कुल भी चिंता मत करो, ठीक है बेटा, because that exponential here it is not exponential, and in that case that was totally different case, ठीक है. सो अभी अगर हम यहाँ पे if we are going to put carbon here, then this carbon is now going to diffuse inside this steel na. So how the concentration is going to change along with time inside this steel? See, where is the graph? See this graph beta, see this graph. Initially everywhere C naught. After some time when you are going to give surface concentration as CS, then at surface CS is there, and this is the graph. थोड़े दूर तक पेनिट्रेट किया, बाकी आगे हर जगह C नॉट ही है. अब थोड़ा और आगे तक पेनिट्रेट कर दिया, थोड़ा और आगे तक फैल गया, अभी भी आगे C नॉट ही है, फिर लास्ट तक पूरा फैल गया, अभी और बहुत आगे जाओगे तो C नॉट ही. So in this manner diffusion is occurring there. In this manner diffusion is occurring there. That means at surface if CS is there, then with respect to time, see time is increasing in this manner. Okay, time is increasing in this manner. So t is going to increase in this manner. इधर को बढ़ता जा रहा है, समय जैसे बढ़ रहा है प्रोफाइल इधर को शिफ्ट कर रही है. Okay, so if you are going to look upon this graph, then initially this was like this. After some time it is like this. After some time it is like more flat. So initially it is like this. After some time the thing is like this. ऐसा कुछ उसके अंदर में हो रहा है, परिवर्तन जो भी है. सो टाइम t1 पे ऐसा टाइम में, तो एनालोगस, इस डायग्राम को आप ऐसा एनालोगस फॉर्म में देख सकते हो, कुछ ऐसा आपका परिवर्तन हो रहा है, क्योंकि बाहर से चीजें अगर आप वापस ऐड नहीं कर रहे हो तो बाहर भी क्या होगा, ये CS की वैल्यू थोड़ी सी घटेगी समय के साथ. अगर आप बाहर बस डाल के छोड़ दिया तो बाहर अभी इतना था, थोड़ी देर बाद बाहर इतना होगा, अभी आगे को था ही नहीं, अब आगे भी आएगा. समझ पा रही हो ना बेटा? सो this is the case that you are going to deal with the help of fixed second law of diffusion. Now you are able to calculate with help of that diagram, that equation, what is the value of concentration of X, concentration of that steel at this X at some time t1. If time is t2, what is the value of this X, what is the value of this C at this X? At some time t3, what is the value of C concentration at the same X, or for any other X also. So ये केस समझ में आ गया ना, कैसा एग्जाम में पूछता है? Case is clear? Now why I told you this is the most important term, because they will ask you problem so that error function is not going to used in order to solve that numerical. उस numerical को solve करने को आपको error function का इस्तेमाल करना ही नहीं होगा, ऐसा क्वेश्चन पूछ सकता है. वो कहेगा सेम डिस्टेंस पे रे भाई, सेम कंसंट्रेशन सरफेस वाला हम दे रहे हैं, सेम, और अगर किसी दिए हुए डिस्टेंस इस x पे यह कंसंट्रेशन है किसी कंपोनेंट A का, और इनिशियली C नॉट था और दूसरे का भी C नॉट ही है, तो बताओ कि कितने समय में, अगर पहले वाले में T1 टाइम लगा तो दूसरे कंपोनेंट में आपका कितना समय लगेगा T2 और T2 बताओ। अगर डिफ्यूजिविटी की वैल्यू पहले D1 थी, अभी D2 है। So all things same, so automatically only this term will be you are going to use. So dt will be constant, d is proportional to 1 by t. This is the most important thing that you have to remember from this equation, beta. If cs cx c naught x same for two components, अगर दो कंपोनेंट के लिए ये सेम देता है, देन d will be proportional to 1 by t. आप बता सकते हो कि इसकी डिफ्यूजिविटी इतनी थी तो दूसरे की डिफ्यूजिविटी कितनी होगी, बस समय अगर आपको दिया हुआ है तो, डिस्टेंस नहीं, सॉरी, समय अगर आपको दिया हुआ है तो. Are you getting my words? One more thing that can be asked, they can ask you this complete thing and they can give you this all is constant. So x by root of dt may be constant if x is not same. So in many terms, in many types you can use this equation where error function calculation is not required. If required, then how they can ask you, don't worry, one numerical is present in this today's slide beta. आज के slide में एक numerical उस पे भी related हमने रखा हुआ है. Okay, and this equation directly you need to remember. Complete equation भी remember करना पड़ेगा if you want rank 1. Okay, otherwise you can leave. If you want just rank under 200, then you can leave. Now see, what is error function? ERF, just this function is similar to sine, cos, tan or cos x, sec, cot. This is known as error function given by Gaussian. That's why it is also known as Gaussian error function. ERF z, if written, then this z is known as argument of that error function. This is Gaussian error function and this z is argument. Maybe in place of z they are writing error 0.75. So this 0.75 is argument of this error function. This is argument of this error function. Actually this is the expansion of this error function and no need to remember it. 2 by root pi 0 to z e raised to power minus y square dy. No need to remember. इसे remember नहीं करना है. Don't remember. No need to remember. No need to remember. इसे remember नहीं करना है. Okay. Now you can see this is the equation that you are seeing here, like normalizing factor that you had seen in mathematics. वैसा ही कुछ equation ये आपको दिख रहा होगा. Normalizing factor. ऐसा जो स्टैंडर्ड डेविएशन में आप बनाते हो वैसा ही कुछ डायग्राम यहाँ भी बन के आता है. Gaussian bell shaped curve. Gaussian bell shaped curve. And the area inside this curve is 0 to z e raised to power minus y square dy. Because the curve is going to follow this e raised to power minus y square. ये यही होता है गॉसियन. ऐसे सारे कर्व जो e raised to power minus y square के फॉर्म में आ रहे हैं. सो उसका ये एरिया, उसी से रिलेटेड आपका होता है एरर फंक्शन. इससे ज़्यादा जानकारी अभी आपको इस क्रैश कोर्स में हम नहीं दे सकते, इतना काफ़ी है. ठीक है, अभी देखो एग्जाम में क्वेश्चन कैसा पूछेगा. ठीक है, एग्जाम में. और एक बात और, एरर फंक्शन जीरो की वैल्यू जीरो होती है, ये आपको याद रखना होगा. Error function minus z can be written as minus error function of z. Error function if plus infinite, its value is plus 1. Error function minus infinite, its value is minus 1. तो ये आपको थोड़ा याद रखना पड़ेगा. If you want rank 1, if you want just rank under 200, then no need to remember. Then no need to remember. See, beautiful problem. As I told you, two cases. Material 1, material 2. Surface concentration here CS1, here CS2, and CS1 is equals to CS2. Two different, like here suppose carbon, here may be sulfur, here carbon, here may be sulfur. Different cases, two different components, and they are asking at this distance, that is x1 here, and in second case x2, and x1 is also equals to x2 at same x. They are giving in problem at same x, and they are also asking same cx. मतलब कह रहे हैं कि एक में सल्फर एक में कार्बन है, तो सेम x पर सेम CX पहुंचने में दोनों में कितना कितना समय लगेगा, या एक में इतना समय लगेगा तो दूसरे में कितना समय लगेगा. कहता है कि इसमें इसको यहां तक पहुंचने में, मान लो यहां तक 4, यहां कंसंट्रेशन 4 यूनिट है. इफ द कंसंट्रेशन हियर इज 4 यूनिट, एंड हियर आल्सो 4 यूनिट ऑफ हु, कार्बन 4 यूनिट, हियर सल्फर 4 यूनिट at the same distance. Then here if timing is 2 seconds, then here what is the value of time? If the diffusivity here is D1 and here diffusivity is D2. ये है प्रॉब्लम आपका, ठीक है. So see, very easy. Same concentration, initial also same x per, same cx. For same cx, if the diffusivity of the first component is A, diffusivity of second component 2A, then for first 24 second time required, then for second case how much time required? So just you had seen this d1 t1 by equals to d2 t2, this one. So t2 equals to d1 by d2 t1, A by 2 into 4, 2 seconds. Very easy. It's very easy. I hope everyone crystal clear about this example or problem number 30. ये प्रॉब्लम नंबर 30 बोलो बेटा, सभी को क्लियर है ना? कैन वी प्रोसीड? कैन वी प्रोसीड? कंफर्म मी माय डियर स्टूडेंट्स. नो डाउट्स, वेरी इजी ना? No, only few more slides are there. Just one more question, then lecture over. Clear? हाँ, एरर फंक्शन कैलकुलेट कैसे करेंगे राकेश? कैलकुलेट नहीं कर पाओगे एग्जाम में. Then sir, how to solve numericals? See this numerical. They will provide you respective data along with numerical. And solve this numerical only if you want rank 1, otherwise you can leave it. You can leave it. Because only these type of numericals they can ask once in 15 years. ओके, इस तरह के क्वेश्चंस को 15 साल में वो एक बार पूछ सकते हैं, इन विच यू हैव टू यूज एरर फंक्शन वैल्यू टू. एंड दिस इज आल्सो जस्ट फार्मूला बेस्ड. क्वेश्चन देखने में बड़ा कठिन है बट फार्मूला बेस्ड है. सी, they had given this as your data, all you have to extract, you have to put, and after solving this beta automatically you will get the same thing here. Okay, now see, putting 0.75 because this value given 0.7143, so automatically this side will come 0.7143 this side. So automatically you will get that this whole value will be 0.75. Now it equals to 0.75, one equation, one unknown t. Solve it. Okay, solve it. So formula based question will come, but still chances are less. ये बहुत ज्यादा इस तरह के क्वेश्चन नहीं पूछे जाते, बट पूछ सकता है. So if you want rank 1, then you can't leave. Under 10 rank, you can't leave. Okay, so see, just formula based. After solving, I got it 175.1 minute. Okay, if asked in hour, then you can convert in hour, 2.918 hour. बोलो बेटा, सभी को क्लियर? Is it crystal clear, my dear students? Any doubt? ये प्रॉब्लम समझ में आ गया सभी को? See, a steel carburizing process is happening at a temperature of 900 degrees Celsius. Determine the time required to increase carbon content to 0.4% at a distance of 0.55 mm. मतलब ये अगर आपका स्टील है, then at some distance, इधर से आपका डिफ्यूजन हो रहा है, then at some distance of 0.55 mm, if the concentration here you want 0.4%, okay, then how much time required for this work? They are giving, assuming that the carbon content at the surface is maintained at 0.9%. So here surface concentration given, maintained always 0.9% throughout the process. पूरे process के दौरान the steel has a carbon content of 0.2%. That means initially C naught here given in terms of percentages 0.2%. The diffusivity of carbon in steel also given. Error function is given in minute. So CS, CX, CS, this C naught. So just I am putting these all directly in terms of percentage. 0.9 minus 0.4, 0.9 minus 0.2. 0.2 is initial concentration everywhere. 0.4, that is you want at that location X. 0.9 surface concentration in terms of percentage. Okay, X 55 mm, so in terms of meter you can write like this, 2 root of D. So D is clearly mentioned here. You have to calculate time. After calculation, left hand side is coming like this. You are going to compare with this. that if left side is this, then right side will be error function of 0.75. Then it should be error function of 0.75. So this 0.75 will be equals to this one. So I am going to write this equals to this one. Now one equation, one unknown. एक इक्वेशन है, एक अननोन है, फटाफट आप सॉल्व कर सकते हो इसे. बोलो बेटा, सभी को क्लियर है? एवरीवन एंजॉय टुडेज लेक्चर बेटा. बहुत सारे टॉपिक्स को कवर कर लिया हम लोगों ने. नाउ इन नेक्स्ट लेक्चर वी विल स्टार्ट मास ट्रांसफर कोफिशिएंट्स. ओके, मास ट्रांसफर कोफिशिएंट. चलो. So one more thing final I want to tell you beta, if you want a great rank, top rank in GATE examination or any type of examination, the key is revision. So don't forget to revise your notes every day beta. I must do my revision daily, 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 I must do my revision daily beta. Then definitely you are going to get rank 1 to rank 100, and in that case definitely it is going to make a beautiful path for your dream job. All the best, take care, love you all, and a very happy good night to all of you. सबने एंजॉय किया बेटा? नो डाउट. PDF will be available in GATE Chemic Learning App. If not downloaded yet, you can download GATE Chemic Learning App. And for link of app, you can WhatsApp or call me at number 9451707049. This is the number, only number that you can WhatsApp to me. इसके अलावा किसी नंबर पे हम WhatsApp वगैरह या कॉल वगैरह नहीं रिसीव करते हैं ना, हम बात करते हैं. ओके, क्लियर? PYQs question, extra question that you can practice from PYQs from mass transfer option, you will see in PYQs batch beta. Okay. PDF अभी तुरंत अवेलेबल करा देते हैं, just after completion. Within 15 to 20 minutes it will be there in your GATE Chemic Learning App. Chalo, take care beta. No doubt, then take care. Love you all. A very happy good night to all of you. All the best.